Okay, baru boleh.
Ya, baru selesai.
Thank you.
Oke.
Sebaik belum jauh lagi.
Tapi belum perasaan tadi.
Okay.
Oke, thank you ya.
Okay, thank you. Right, so for this kind of fuel and battery, that is the challenge. So we want to use electric vehicles, but we need more space and it consume more weight for our vehicles, for the car. So that is why we look at the car before, BYD or Tesla. So they are normally below than 100 kilowatt hour. Some of 30 kilowatt hour battery. So because of the additional weight given from the battery to the vehicles. Okay, so net energy density for gasoline, diesel, ethanol, this is a liquid petrol gas compared to the net energy density for the battery. So the net energy density lithium ion battery is lower than the gasoline, than the gas. That is the research continues going on, and just this week I got the info or news about the nuclear battery. Have you heard about nuclear battery?
No, doctor.
Okay.
Go ahead. Okay.
Nuclear battery. Baru this week. This one. Nuclear powered battery. This is 18. So yesterday. Yesterday. Okay. Chinese developed nuclear powered battery that can last 50 years without recharging. Smaller than a coin. And then it lasts longer. So this is just a research in China for battery. So the current research is about you want to make the net energy densities of the battery so you have smaller size battery with the high capacity that can move the car. Okay, so then it will be ideal for us to use the electric vehicles rather than put on extra weight of 500 kilograms to our car to put the battery on the vehicles. So that's the issue. And how do you compare how big, how volume, the volume of the 1 kilogram of iron metal. Okay, 1 kilogram iron metal is something like this, so 1 kilogram. But how big is 1 kilogram of cotton? So it's the same 1 kilogram mass, but the cotton is I think the full of your room, 1 kilogram, something like that. So that's the comparison of the energy density of the fuel of the gasoline and the battery. Okay, so we want the smaller size but give higher energy. Next, it is about cost. If you add something new technology, it will cost you higher. So key to enabling the widespread availability of sustainable transport is to provide solution which customers can afford to purchase. It is all about market survey. So we want the new technology with lower price. Okay, so if we compare something like vehicles that we have, uh, let's say Honda City, okay, Vios, with the new technologies of ADAS system, Toyota preventive system, something like that. So comparing Honda and Toyota with 100 ringgit, 100,000 ringgit, with Product Atiba, Product Alza with 75,000 ringgit. So that's the comparison of the affordability by consumers. So we want to introduce the new technology with lower price. So customer can afford to buy. Okay, so we compare the cost of using gasoline. Okay, so this is the graph of using gasoline. This is battery electric vehicle with range 550 range, 350 kilometer range. So the lower range will cost you a lower price. So we had a look. We have look at the comparison between Tesla standard and also Tesla extended range, long range. Okay, so the 100 kilometer extra costs you about 30,000. Okay, so costs you about 30,000 for 100 kilometer extra range. So higher the range of your battery can do, so higher the cost. Okay, so this is range. This is EREV. This is proton electron membrane. This is a fuel cell. Okay, fuel cell FC. That the roadmap that I shown to you for the battery, full electric battery vehicles and the fuel cell. So this is the assumption that cost to introduce the new technology in our car. Okay, so next, this is the fuel cell. So we have fuel cell. The fuel cell is what do we want in fuel cell? Fuel cell. We want hydrogen. Okay, so we want hydrogen. Then the hydrogen will separate the electron and proton. So the electron will make the circuit give the energy, and then the hydrogen combine with oxygen, and then we get H2O for the waste. And then we use back again H2O, and then electrolysis to get hydrogen and oxygen. Hydrogen will use to electrify the vehicles to give the energy, and then that's the process of the fuel cell. So now, this is some kind of the vehicles with the fuel cell. So we have the battery pack, and we have the gas storage, not gas, hydrogen storage tanks. Yeah, gas. Fuel cell stacks, power control unit. So this is the motor and also the gearbox. So that's how the new technology or future car works without engine. Okay, the third one is when you, yeah, that is research. When you change from ICE to electric or ICE hybrid with the electric motor. So hybrid, we got the hybrid car. We need the electronic control module to define which one that we need to use. It is either petrol, gasoline, or the battery. So that's how we use the electronic control module. So that's a research so that the jerking of starting and stopping the ICE engine will not feel by the passengers. Okay, so that's the study. Okay, next we go to the market penetration of biodiesel. So biodiesel have been used in Malaysia. It's about B7 and B10 biodiesel. So market penetration of biodiesel. I think the biodiesel is until B20 as for now. But research are currently going on more than that. B30, B50 still in a research. Renewable liquid fuels are potentially pragmatic route to decarbonizing transport because they provide evolutionary transition for both vehicle technology and fuel distribution infrastructure. Okay, the EU dominated production of biodiesel in 2009, so 15 years back, is 54%. So EU 54%, and then yeah, US, Brazil, about 75% of EU biodiesel is made from rapeseed. Okay, so we have rapeseed oil, soybean oil, palm oil. So palm oil, Asian country like Malaysia, Indonesia is from palm oil. China and India produce 2% and 1% of the world's biodiesel. Germany use pure B100. So the oil from rapeseed produced by Germany. Vehicle manufacturers raise compatibility concern regarding use B100 rapeseed oil with modern common rail fuel injection system, particulate filters, oil dilution, degradation, deposit formation, and materials compatibility. So there are pro and cons in introducing the biodiesel to the market. So, but Germany says use the B100, but consumers are worrying about the wear and tear of the engine. Okay, so this is in Malaysia, I think, to be implemented B10, 10% palm oil and 90% fossil diesel. The benefits of the biodiesel is reduce greenhouse effect, okay, carbon dioxide, reduce emission of carbon dioxide by 10% per year, improve air quality, and increase palm oil demand. So dapat can improve the higher price of palm oil lah. Okay. So this is alternative road transport fuels by energy. So we have OL OL family. We have ethanol, single C, methanol, butanol. Okay, and then we have FAME biodiesel. So it is biodiesel. FAME is come from the rapeseed, soybean, palm oil. hydro-treated biodiesel, GTL, CTL, NGV, biomethane, LPG. So natural gas is NGV, LPG is what we use in Malaysia. We use LPG in cooking. So gas, LPG gas. Okay, so we look at the penetration of alcohol fuels back in 10 years ago. In the market. So alcohol fuels have a great octane number, so high octane, so reduce the knocking. So alcohol fuel is a high octane number, knocking inhibitor in gasoline until tetraethyl lead came to dominate the market. So before this, alcohol fuel is very good, but until tetraethyl comes, so tetraethyl lead cause the emission. It is not emission; it is about healthy, safe and healthy, because of the lead. Okay, plumbum. Okay, the US produced 56% of the ethanol consumed by the road transport sector. So 56%, Brazil 33%, and European Union 4%. So up until 2011. Okay, so that's the fuel. So now alternative and renewable liquid fuels to improve the environmental performance of ICE engine. So this part is explaining or discussing about the engine fuel for the engine, how to move the car. Okay, so from pure petrol, gasoline, pure diesel, going to ethanol, methanol, biodiesel, and up until the fuel cell, PEM, proton electron membrane fuel cell. Okay, so this is the use of biodiesel in ICE. So up to now we have B20, okay, B20, and the blending come with the standard ASTM. Okay, the ketane number of FAME is dependent FAME all family, OL family, fatty acid, methyl ester is dependent on the distribution of fatty acids in the original oil. So this comes from the rapeseed oil, palm oil, and what we call the one soybean. Okay, soybean oil. Okay, so oh ada kat sini. The original, so the fatty acid is from the oil. The ketone number of biodiesel, soybean methyl ester, 45 to 60. Rapeseed methyl ester, 48 to 61. Palm oil methyl ester, 59 to 70. So this is the ketone number of the bio oil. Okay, so the wide variation of the fatty acid methyl ester composition due to effects on low temperature operability, fuel pour point, fuel oxidation stability, compatible with the vehicle fuel injector, oil deposits, and fuel dilution on the engine lubricant. So this is come up with the wear and tear. So wear and tear of the engine. Firm-based biodiesel, good in lubricating the fuel pumps and fuel injectors compared to petroleum. Blends up to 20%, biodiesel, 80% petrol. This is the ASTM number. So it provides good compromise in balancing cost, emission, cold weather performance, and materials compatibility. So it means that when we use biodiesel, so 20% 20% of bio oil from rapeseed oil, from soybean oil, from palm oil, so maximum 20%. We don't don't need to change our major ICE engine, so not required modification. But not all diesel engine manufacturers warrant their products for use with such blends. Not all manufacturers. Some of the manufacturers mention or put it in the manual. So the maximum you can use is B5. Maximum is B10. So maximum is B20. Just for me, my idea is to make sure it will not affect the engine power and also engine performance. Okay, so the use of FAME as a fuel can cause increase. So bio oil can increase nitrogen monoxide emissions, but it will reduce others emission, carbon dioxide, carbon monoxide. Okay, so this is the biodiesel. Apart from the biodiesel of soya bean, rapeseed, and also palm oil, we have also alcohol fuels. Alcohol fuels for spark ignition engines, for petrol engines. Okay, alcohols have, so this is normally okay. So this is normally in diesel. This is on the spark ignition engines. Okay, so petrol. Alcohols have been used as a component fuel blends with gas or as the dominant fuel blend constituent themselves. This is so single C, double C, and 4C. Ethanol, methanol, sorry, methanol, ethanol, and butanol. Okay, fatty acid methyl ester based biodiesel, however, the presence of the oxygen atom reduce the energy density of the fuel. So this is the about the energy density. In 2006, Nakata used high compression ratio in naturally aspirated petrol fuel injection, spark ignition engine, and found that torque increased by 5%. So normally in petrol engine, the compression ratio is around 10 to 11, 10.2, 10.3, 10.5. This is the compression ratio. So the compression ratio is from the whole the whole centimeter cubic, so bottom dead center until top dead center. So the when the piston move to the top dead center, that is the 1 ratio lift compared to the 13 ratio for the whole cylinder. So normally we have 10 compression ratio, but Nakata use high compression ratio for the ethanol 100, improve the torque of the engine up to 20%. So Nakata compared the operation on 100 RON and 92 RON gasoline respectively. So This have been done by Nakata. So using ethanol 100 full load at 2,800 RPM give 39.6% compared to using the RON 100 and RON 92 gasoline, which is lower than the E100. Okay, so it shows that it improves the capacity, the performance. Okay, next, vehicle and blending technologies for alternative liquid fuels. Ethanol gasoline, methanol gasoline, biofuel vehicles. Okay, so biofuel vehicles is we have two independents. Some kind like we can call it hybrid, but two system of fuel. Okay, so biofuel is a two fuel system. Each system separated for storage. Okay, so major application, the main fuel used in a downsized engine would be gasoline. Engine will be modified to operate with higher boost pressure, compression ratio, and alcohol will be directly injected to help suppress knock at high load. So different. The alcohol will be only used when necessary. So gasoline and alcohol. The alcohol biofuel operation, some kind of diesel plus PNG compressed natural gas with pilot injection of diesel for ignition purpose is also possible. So future dedicated spark ignition compressed natural gas engines are likely to be used widely since the cost of the diesel injection equipment is very high. So spark ignition is petrol compared to the diesel. Natural gas does bring reduction in greenhouse gas emission over 20% due to its high hydrocarbon ratio. So hydrocarbon in chemistry, so hydrocarbon plus oxygen ignition, and then we have carbon and also H2O. So that's the ideal way of combustion. Okay, so this is by fuel system. Use LPG. So LPG in Malaysia, we use NGV before this. So NGV. So we have fuel tank, and then we have the storage for the gas. Okay, gas tank. So there are two different storage for fuel and also for the gas. And we have the switch to use gas or petrol. And then we have the engine control module, gas injector, pressure regulator to control when we switch from gas to petrol or petrol to gas. So this is additional. We don't call it as accessories, but it can be defined like it is the accessories, because the NGV tank, LPG tank will be installed in the boot that consume your space, boot space, and then it will be running on the system, and then we need to install the module to control between switching the gas and the petrol. Okay, so we just what we call a plug and play, something like that. But we need some modification of the switch to conducting the operation of the gas and the petrol. So I can't remember which year, but it is around 2000, 2009, 2010 that there are a lot of workshop introduce the NGV and NGV tank, and it is the price is depends on the size of your tank. So more tank, more I don't know it's about liter or what, but 60 liter, 30 liter of gas that can be compressed into the tank and then can be used as the energy to move our car. Okay, so this is consume the boot space, some of the boot space, but the price of the NGV is lower compared to the petrol. So let's say 30 liter tank of NGV of the gas, you can fill in about 10 ringgit, and can go up to 400 kilometers. Okay, so but now most of the NGV station is not there. So I don't know what happened to the NGV gas station, but people are not using NGV because the price is double up from the previous price of NGV. Okay, so when they compare to use the petrol back. Okay, so that's what happened for the NGV in Malaysia. Okay, so I think this is the last part for the gaseous fuels. Okay, for this gaseous fuels. Okay, at ambient temperature and pressure, gaseous fuels are much less energy dense than liquid fuels. Gaseous fuels, fueled vehicles can require a significantly larger volume of fuel to travel comparable distance. Gas transportation fuel include fossil natural gas, so natural gas, biomethane, LPG, liquefied petrol gas, and also hydrogen. Okay, so we look at this one. Natural gas has potential to reduce emission from bus, taxis, which operate in congested urban environments around the world. Demand increase due to the shale gas reserve. So we can look at the China, Argentina, Algeria of the shale gas reserves in those countries are higher. Most compressed natural gas fueling stations are connected to low pressure, 2 bar, and then compressed to the higher bar on-site buffer storage, and lastly dispense into the vehicles at 200 or 250 bar. As with other liquid fuels, once natural gas has been liquefied, the most practical long-distance transportation mode is bulk transport via ocean, tanker. Okay, NGV engine and vehicles. Globally, there are approximately 15.2 million natural gas vehicles. I don't find any NGV car. I think maybe last 5 years. Okay, on the road in 2012. Second most widely used alternative motor fuel after LPG. Natural gas has high octane rating, around 120, increase in power in spark ignition engines. Natural gas occupies a larger volume in the engine, so you need the bigger cylinder than liquid fuels, which is tank. Same like what we have discussed before for the volumetric efficiency of the net energy density about the battery and also petrol. So comparing gas and petrol, so gas is much more larger volume compared to the petrol tank. Okay. Natural gas spark ignition lean burn engines operate air fuel ratio higher than stoichiometric. So the stoichiometric air fuel ratio is higher. So lower combustion, lower exhaust temperature. So we need a turbocharge to make up the loss. The advantage is engines operates more efficient, but the disadvantage is emission standards for the NOx. Biomethane. So biomethane is renewable gas. It comes from the waste from livestock, crops, wastewater, food waste. So we put it in a bin digester, and then it will we call it fermented and expel the gas. Also digested biogas, so we can have the biomethane and others to fertilize soil, livestock beddings. Okay. So the decomposition of organic matter, this is organic, manure, sewage, municipal waste, green waste, plant material, food waste, and crops are going to the anaerobic digester. Unlike fossil natural gas, which is composed mostly of hydrocarbons, so HC, 70% or more methane, CH+, propane, butane. But biogas contains somewhat less methane. And also carbon dioxide, water, nitrogen, hydrogen, carbon monoxide, and contaminants. Biogas is formed by anaerobic digestion. So some kind of like fermentation. In Malaysia, alcohol fermentation. Kalau orang Melayu, tapai, something like fermentation, and gassy. So you later you come out with the gassy, so that you can use the gas to uh, to move the vehicles. So biogas is formed by anaerobic digestion, a chemical process which several kinds of bacteria digest organic matter. So this is organic in the absence of oxygen. Okay, this biogas plant. Sorry, excuse me. So from livestock farming, from biowaste, from stalks, from manure, whatsoever. So put it in the bin collector, and then going to fermenter tank. So with light and oxygen excluded, the biomass is digested by anaerobic microorganisms. So bacteria, microorganism that will work in the gas tank, in the storage. So it will produce the gas. Okay, so after that, when we have gas will be go to the storage, gas treatment plant, gas bio fuel station, and then it will go around again and again. Okay, so for the residual materials, will use to the sludge down in the tank will use to the crops, will use to the biomass. Okay, agro production. Okay, so this is the how the biogas, biomethane were produced, which is a renewable gas. Okay, so LPG. So we have looked at the uh, biofuels, biodiesel. We have looked at the NGV. We have looked at the biomethane, and now we look at the LPG. So liquefied petrol gas (LPG) is the most widely used alternative motor fuel. LPG is Europe leading alternative fuel with approximately 10 million vehicles. So LPG gas kat rumah lah, our home gas. 10 million vehicles using it in 2013. But I never see it in Malaysia because I don't know, because we have NGV maybe before this. So 3 grades of LPG is HD5. HD5 is 5% polypropylene, HD10 10% propylene, and commercial grade no limit of propylene. LPG is high octane and it is amenable to the spark ignition IC engine. LPG is an attractive automotive fuel, so can use to move our car. Shale gas in North America is pending to supply propane and other natural gas as shale gas producer in response to low natural gas price. Back in 2010, 2015, NGV and LPG is the technology that thing will be replace ICE engine. But from my readings, it is currently going lower compared to electric vehicles. Okay. So LPG tank is typically mounted in the trunk boot at wake to a vehicle. So there's a pro and cons. You need to plug and play. It's just like you add additional load to your vehicles, and it will reduce the fuel consumption. Okay, so increase fuel consumption. Energy content of LPG is about 75% that of gasoline. More fuel is needed to travel an equivalent distance. Last but not least, we have hydrogen. We call it fuel of the future, because the hydrogen give zero emission energy. They claim zero emission energy because from hydrogen that move the car and then combine it with oxygen, and the waste is water. So hydrogen offers an appealing prospect, limitless supply of carbon-free and zero-emission energy, although can be burned in internal combustion engines. Doing so does not provide the energy efficiency needed to offset its low energy density. For H2 to realize its potential, it must be paired with highly efficient fuel cell electric vehicle. The challenge is producing mass market FCEV to compete with ICE engine and producing H2 in economic quantities. So H2 and we know that H2 and H2O. So from H2O, we need the process called electrolysis. So the process of producing hydrogen gas from the electrolysis must be rapid, so to provide the energy to our car to move. Okay, so hydrogen fuel price is about $13.14 USD per kilogram, which translate to an operating cost of 21 cents per mile, compared to spark ignition engines that can tolerate fuels with attendant properties. FCEVs required high purity H2. The hydrogen use only H2 pure. Okay. In nature there are no hydrogen, but it is combined with oxygen, and we call it H2O. Hydrocarbons, fossil fuels, CH, carbohydrates, and other compounds. So H in H2O, in hydrocarbon, HC, in carbohydrates, in ethanol, methanol, all family. And electrolysis is the most common method to use to split H2 from water. Reforming is the most common method of separating H2 from hydrocarbon. So hydrogen production, you need to produce the H2 from water, and then we want to put it in the tank. Okay, so in the tank. So hydrogen production, steam reformation, we have methane, H2O, and then we have H2 and CO, carbon monoxide. This is not good. So electrolysis, using electricity are not cathode, so we can produce H2 and O2. Instead of using battery to store electricity, FCEV use fuel cells. So fuel cells is the cells. We call it fuel cells electric vehicles. Use electrochemical device that produce electricity as needed from hydrogen stored on board the vehicle. So we have anode, cathode, and then fill in hydrogen. So H plus is moving through the membrane. Electron is moving to the flow, electricity flow, so that the electricity of the electron will move the motor. So it is the load. So the electron, and then H will plus with the air, and this is the dissipated water go to the exhaust, so water. So fuel cells technologies is proton exchange membrane. Fuel cells are considered most suitable for vehicular application because of their rapid startup and response and high power density. The main benefits of FCEV are high fuel economy, 3 times greater than gasoline ICE, and zero tailpipe emissions. So the current technology on hydrogen, on producing rapid producing hydrogen, electrolysis, how do you want to produce higher hydrogen volume to store in the hydrogen tank, and then transfer it to the tank in the car to use as the fuel cells. Okay, so that's the future of the technology for green technology vehicles. So lama lagi, 50 years in the future, we can look at the no ICE engine, and there are more electric vehicles and fuel cell vehicles. Okay, so that's all for today. I will give the notes to both of you. I will PM the notes after we finish our class. And also, I will give you the link for the recorded class for today, both. Okay. So, any questions? Everything's okay? So, this is the comparison of the a price for the range. Okay. So, 190, let's say 190 my 220. So this is about 30,000 difference to move to get 100 kilometer more. Okay, so 629 513 30,000 for 100 kilometer. So you need to compare, you need to make you need to study how long that you can get the ROI. Let's say return of investment. If you buy the long range of Tesla Model 3, something like that. Okay. Okay. So I think that's all for today. So we have one more chapter, which is LCA. So for the LCA, we will see in next Tuesday. Okay. In the morning,
Okay.
9 o'clock in the morning. So just that chapter, and then you can. I think we can finish it in the morning. It's not so much of the life cycle assessment. Okay, I stop the recording and